Hello everyone, welcome back to my YouTube channel Data Toolkit. In today's tutorial, we will learn about the Azure Databricks fundamentals. In that, we will cover the big data and the distributed process, then introduction of the Azure Databricks architecture, cluster management, and how we will start with the Databricks like community notebooks, what is magic command, and the file system and notebook utility. So let's start. We see the data approach, what data approach is using by the Databricks. So when handling big data, choosing the right architecture is key, right? So should we go with the monolithic approach or distributed approach? So let's break it down. So in monolithic approach, everything runs on the single machine. So you can see RAM, storage and processing. These work fine for small applications, but as data grows, it becomes slow and insufficient. It can't scale properly, which lead to the performance bottleneck. So that's why Databricks does not use the monolithic approach. If we talk about the distributed approach, so in distributed approach, we use the cluster group of multiple machines working together. So you can see here each machine has its own RAM and storage and they share the workload. So these improve the speed, scalability and the reliability. So making it perfect for the big data processing in Databricks. So that's why Databricks use the distributed approach because it follow the process, that is the massive data set efficiently using Spark cluster. Instead of one machine doing all the work, multiple machines handle different part of data and making it super fast. So in this slide, we will discuss about the traditional Hadoop map reduce processing. So how the Hadoop is this slow in the process. So you can see here, first the data is stored in HDFS disks, that is the Hadoop distributed file system. When processing starts, Hadoop read the data from the disks. You can see here, it will read the data from the disks, and then the iteration 1, it processes the data is proceed, but instead of keeping it in memory, Hadoop write back to the HDFC. You can see here. So again it will write the data and again it will write to the HDFS disk in the iteration 2. So after processing, it write the final output back to the HDFS disk. So why is this slow? The Hadoop read and write the data to disks multiple times, making it slow. So that's why we are using Apache Sparks here. So we'll discuss into the next slide. So you can see here, instead of reading and writing to disks repeatedly, it Spark load the data into the RAM memory. So once in memory, Spark can process multiple iterations without needing to read from the disks again. This makes data analysis much faster. So you can see in the step 1, first Spark read the data from the HDFS and load it into the RAM. Okay, then iteration 1, 2 and 3, the data stays in memory, allowing Spark to quickly process multiple steps. And you can see in the third stage, the analysis the data efficiently. So you can see the Spark avoid frequent disk reads and writes. It runs much faster than the Hadoop. So Spark is 100 times faster than Hadoop for many tasks because it processes the data in the memory. So that's why Databricks use the Apache Sparks instead of Hadoop. So in today's tutorial, we have seen the data approach, Hadoop map reduce and the Apache Sparks. So remaining these all the topics we will cover into the next lecture. So thank you for watching. If you feel this video is informative, please like, comment and share my video, and don't forget to subscribe my channel Data Toolkit.